Alright, everybody, let's learn how to complete the square. We're just going to look at an algebraic approach. There's graphical approaches that you can find if you look around online, but I'm just going to focus on a pattern that you can follow, algebraic approach. So the idea here would be that we were trying to solve for x, and we're going to solve this equation by completing the square. So here's a little pattern that you want to follow. First, what you want to do is find the coefficient of the term that goes like x to the first, or just the coefficient of the x. And you can see that the coefficient of x is -8 here. So then what you want to do, and I guess this is like the toughest part, is whatever that coefficient is, you want to divide it by 2, square it, and add it to both sides. And we'll talk about why this works later. So divide it by 2. So that would give you like -4. And then when you square it, you'd get 16. And then what we're going to do is add that 16 to both sides. Of course, you have to do it to both sides because that will preserve the equation that you have here. If you're going to add it to one side, you got it to add it to the other side. So we just added 16 to both sides. Well, why did we do that? What you can realize now is with the first 3 terms here on the left, you've made a perfect square. So this polynomial x squared minus 8x plus 16, as it turns out, is a perfect square. And we'll talk about that in a moment. So that term right there, that set of 3 terms, is just x minus 4 squared. If you FOIL out x minus 4 times x minus 4, you'll get these 3 terms. So we've completed the square by adding the 16. So this was a perfect square, and then you still have that 10 kind of floating around in there. Well, so as our next move here, all we'd have to do is take away 10 from both sides, and we'd have x minus 4 squared equals 6. Then we could take the, square root both sides, and what you'd see is x minus 4 must then be plus or minus root 6. And then it's just a matter of adding the 4 over to the other side. So then you'd have x is 4 plus or minus root 6, and that would solve this. So that's the plan. Let's look at one more example just to see how this works. We'll follow the exact same plan. So we're going to complete the square in order to solve this quadratic right here. So first thing we're supposed to do is find the coefficient of the x, and it's 24. So there's our coefficient of the x. The next thing that we need to do is divide it by 2, square it, and add it to both sides. Well, if you do that, if you divide 24 by 2, you get 12. And then when you square that, you get 144. So let's add 144 to both sides. You got to add it to both sides in order to keep the equality. And then once again, you want to realize that by adding the 144, you've made a perfect square. These first 3 terms are going to be x plus 12 squared. Again, we'll revisit why that's the case in a moment. And so we have x plus 12 squared plus 44 is 144. So our next move here would be to subtract 44 from both sides, leaving us with x plus 12 squared equals 100. Then what I would do is take the square root of both sides. So you'll have x plus 12 is plus or minus 10. And then what I would do is just subtract the 12 from both sides. So you'd get -12 plus or minus 10. So your 2 answers in this case, I guess, would be what? -2 and -22 should solve this equation. Now, how do we know we made perfect squares with this second step here where you divide by 2, square it, and add to both sides? Well, you may remember from Algebra 1 that if you have something like x plus some stuff squared, if you multiply that out or FOIL that thing out by realizing that x plus some stuff squared is just x plus stuff times x plus stuff, you by the time you multiply, say, the first 2 terms together, you get x squared. When you do the outer and the inner terms, you'd get stuff times x, but twice. And then your last term would be stuff times stuff. So your form of a perfect square looks kind of like this. X squared plus 2 times some stuff plus some stuff squared. Well, so since that's what you get every time you take a perfect square, every time you square a binomial, you can then see why our little scheme works. What I told you to do in our little plan for completing the square was first find the coefficient of the x. Well, that's right there. And then I told you to take that coefficient, divide it by 2, and square it. And add to both sides when you're completing the square. And that's where this term came from when we were completing the square. So the key is to realize when you have something in this format, you already have a perfect square. So if you have something like this, x squared minus 6x plus 9, you don't want to try to solve this by completing the square because you already have a perfect square. You have a situation where half of the negative 6, which is negative 3 squared, is 9. So this thing already is a perfect square. And frankly, given the fact that you're learning completing the square now, your teacher likely assumes that you know this already. So this pattern is something you really need to get to know. That this is already then a perfect square. And so this is just x minus 3 squared. So that's the general game plan for completing the square. Again, if you're faced with solving a quadratic, you want to find the coefficient of the x, divide by 2, square it, add it to both sides, and then you'll have made a perfect square.